Okay, we move to the next example here. For recycle and bypass, air containing 4% mole of water vapor is to be cooled and dehumidified to a water content of 1.7 mole percent. So let me prepare the diagram first. So the stream of fresh air, okay, we have the fresh air first. A stream of fresh air is combined with the recycled stream of the previously dehumidified air and pass. Okay, we have a cooler here. It's the cooler. And we have also the recycled stream. Okay. Okay. So the fresh air contain of 0.04 water, and also what else we have? Dehumidified. So the balance is, so we have two material, air or dehumidified air, and also the water. So we have 0.96 dehumidified air, and then it produces 0.017 water. So the balance is 0.983 dehumidified air. Okay, and then the blended stream entering the unit contain, okay, 2.3% mole of H2O here. So it entering the unit. That's mean we have this 0.023 water, and the remain is 0.977 Da. Okay, in the air condition, and some other water is the feed stream is condensed and removed as a liquid. So we have a liquid water in a liquid. Fraction of dehumidified air leaving the cooler is recycled. Okay, the remainder is delivered to the room temperature, or the room to deliver to a room. Taking 100 mole of the dehumidified air delivered to the room as a basis calculation. Calculate the mole fresh feed, moles and water. Okay, this is what we already extract using this the information given. So we need to define the unknown variable. So we start with N1 here, mole as the fresh stream, and then we have N2 mole mixed with the recycled stream, and maybe we have N3 mole for water only, and then we have N4, and we have maybe this is our N5. Okay, the composition here, because there is no unit operation here, there is no reaction occur here, and so the composition should be same, right? So we have, maybe you can 0.017 water and 0.983 dehumidified air, and same to the composition at outlet stream here, and we have 0.983 dA. Okay, so we already understand what is the system is about, and then we define the unknown variable. Okay, and then we can start our calculation with the first is prepare the DOF. Okay, for the overall system, so you need to have the boundary. We have the overall system, the boundary. So we have the input here N1, output 100, and output N3. So for the DOF, unknowns variables, we have 1, 2. Okay, and then what else we have? A balance. So balance we have 2, since we have 2 component here. Then DOF for overall, then DOF for here, maybe we can name as the mixing point. So unknown, we have, I can draw a boundary here for you too. So we have a mixing here, and 5, and 5, and 1, and N2. But we can determine the N5 if we can find the N2 and N1. So it turns to unknown is 3S2. And then balance unknowns are 2. Balance here we have 2. Balance because we have 2 components here, so it turns to 0 here. And then DOF at cooler. So unknowns, we have how many? 1, 2, 3, but we can determine as 2 because entry we can obtain 8. Balance, we have 2 as well. Okay. And then DOF at splitting point. I call as this is at splitting point. So we have unknowns. How many unknown? And 4 and 5. So we have 2 unknown. And then the balance, we have only 1. Okay, why? Because we have the identical composition here in this tree. So it turns to 1 only. Identical composition. So we have on this, we can solve, okay, cooler here. So we can solve this overall. Maybe we can start with the overall first. So balance at overall system. To perform the balance, we can start with the overall for that particular unit, and then we move to the component balance. So for the overall balance here, we have N1 equal to N3 plus 100. So N1 equal to N3 plus 100. So we have 2 unknown here. Maybe we can, okay, this is overall balance. So we can start with the component balance of because this is water, we will try to eliminate this one. We may use the balance at dA or dehumidified air here. So we have N1 0.6 and 0.96 equal to N3. We don't have N3 for the A here, and the modified have because N3 contain a water only, so equal to 100 times what's the 0.983. So N1 equal to, let me check the answer, 102.4 mole of fresh feed. Okay, and then we can determine our N3. But you insert this value, N3 equal to 2.4 mole H2O condensed. Okay, condensed. So the second is we may proceed to the balance at mixing point. So we perform the overall balance here. Overall balance at the mixing, we have N1 plus N5 equal to N2, N1 plus N5 equal to N2. So N1 is given, N5 we don't have, as well as N2. So we perform the component balance of maybe we can choose the component balance of here at the water or dA. So I choose the water first, of water. So we have N1. For the water here, we have 0.04. And then plus N5, we have 0.017 equal to N2. Also, we have the 0.023. So N1, you can insert the obtained value plus N5. Okay, 0.17 and 2. So you have 2 equations here, 1 and 2. And then after you can perform the parallel equation. So finally you can get N2 equal to 5 mole. And then N5, 290 mole. So recycled. And then back to here. So let me change the color. So we already determined N1, N5, N2. So in a cooler, we can proceed to N4 and N3, right? Or on N3 already determined, right? So N3 already done. So we can determine the N4. Okay, so I just write up the answer for N4. Once you perform the balance at cooler, So only require a compound overall balance. No need to proceed with the balance. So we have N4 here. You can find the N4. Okay, let's take a look back to the question. So it asks us to determine the fresh fluid. Okay, we have done. Mole of water content also done. Mole of dehumidified air recycle. Oh, basically we already cover here all of that. So we have done we already solved the problem. Okay, if later you need to require for you to determine the N4 and etc., you can use that the same method, perform the balance for each unit.